This is the screencast for section 6.4, example 1. We're going to explore polar coordinates. Polar coordinates are, first of all, used on your calculator under mode and then polar. But the polar coordinate system is a plane, essentially x and y coordinate plane, with the point O, which is the origin, and there's a kind of a pole sticking out of your piece of paper through the origin where the terminal ray rotates around that pole. The polar axis is always your positive x-axis, the initial ray, we used to know it as when we did trig. R is the directed distance from O to P. So if R is greater than 0, it is P is on the terminal side. If R is negative or less than 0, it's going to go the opposite direction. And theta is your directed angle whose initial side is on the polar axis and whose terminal side is on the line OP. So I have a demonstration here that I'll show you to kind of get a better idea. Now we have an equation that we could make in rectangular mode or function mode for this circle, but in polar coordinates, here's what happens. You have your points are r comma theta. R is kind of like your radius, and then theta is the angle at which that radius is used. So in this case, as we sweep through the different angles starting at 0, theta is going to get bigger, and our radius is changing, creating this circular pattern. And then we keep going. Radius is getting smaller and smaller and smaller as theta gets closer to pi over 2. Now as theta crosses over pi over 2, as theta becomes bigger than pi over 2, now our r values are getting negative, going the opposite direction. They're getting longer and longer, or more negative, to create the rest of that circle. Keep going, keep going, keep going. Now after around pi radians, exactly pi radians, we have completed that circle. So that's kind of the idea between polar coordinates. Now you'll see more about why r equals 3 cosine theta draws a circle in later examples, but I wanted to give you an idea of what drawing a polar graph looks like. So let's start with the basics. Example 1, plotting points on the polar coordinate system. Plot the points with the given polar coordinates. So this polar point has r equals 2 and then theta equals pi over 3. So I know what theta at pi over 3 looks like, probably about here. And then, assuming that is a radius of 2, there is my point, my polar point, 2 comma pi over 3. So at theta is pi over 3, I used a radius of 2. In part B, if you notice, we have a negative r value. So it's going to go the opposite direction of our terminal ray. So first of all, the terminal ray is going to be at 3 pi over 4 radians. Terminal ray is going to go into quadrant 2, but we're going to draw it backwards. The distance of -1 units. Q, -1, 3 pi over 4 is actually in quadrant 4. Part C, we're going to use a little degrees. So -45 degrees is right here in quadrant 4, going backwards. But this is still a positive r value, so now it will actually land in quadrant 4. So here's that point, r, 3 comma -45 degrees, and then that distance for the point from the origin is 3. The now try problem number 7 is using a a theta of 4 pi over 3. It is a positive r value, so the terminal ray lands in quadrant 3, and the point is also going to land in quadrant 3. So there is 3 comma 4 pi over 3. The distance of the point from the origin is 3.